Hello students, this is Kumar Physics. Today I am going to discuss about the chapter electric charges and fields for class 12. So please subscribe channel Sri Sai Physics for Mains and NEET. Okay. So this is an encouragement from you to discuss about all the chapters. Already I uploaded the first year chapter units and measurement. Now I am uploading the electric charge and fields. So after that I will change the track on first year, second year, like that. Okay. Now today we are going to discuss about the electric charge and fields. So before doing this, what are electric charge? What is meant by electric charge? What are its properties? So what is the branch named about the charges at test? That means the branch of physics which deals with charges at rest is called electrostatics. And the charges in motion, then it is called electrodynamics. Next point, what is meant by an electric charge? What is meant by an electric charge? So if you consider a single atom or a single body, the body is made up of number of particles. According to Bohr's theory, all the electrons revolving around the nucleus in a circular orbit. That means the matter made up of number of atoms or molecules. Right? That means for each molecule or atom, the electrons are present within that, and with having a nucleus, and all the electrons are revolving around it. That means it is called the fundamental property of a matter. So the electric charge can be defined like this: the fundamental property of the matter which will produce both electric and magnetic fields. The fundamental property of the matter which will produce both electric and magnetic fields. When the charge will produce electric field. So when the charge is stationary, it produces electric field only. When the charge is in motion, it produces electric and magnetic fields. Electric and magnetic fields. Next point, when the charge is accelerated, it produces electric, magnetic and electromagnetic radiation. Okay. Next, how many number of charges are present? So the charges are two types. One is called positive, another one is called negative. For any body, the total charge becomes 0. That means it contains, if the charge is indicated by Q, the total charge on the surface of a body is equal to 0 means it contains equal number of positive charges and equal number of negative charges. Okay. So next, law of conservation of charge. Law of conservation of charge means total charge in the universe remains constant. So there is neither charge flows nor total charge in the universe remains constant. So as the charge flows from one body to other body or does not pass, the total charge remains constant. Okay. If two bodies having charges Q1 and Q2, if they are connected by a common wire, then they will acquire a common potential. They will acquire a common potential. Next, the charge can be produced. The charge can be produced by three methods. The first one is called conduction or contact method. So in this conduction, so let us consider a glass rod. Now it is rubbed. Or let us consider a glass rod which contains a positive charge. Let us consider another rod which is having the charge 0. Okay. Now this positive charged body is in contact with the neutral body. So then what happens after connection? Both the bodies will acquire positive charge. As the positive charge is obtained by both the bodies equally, then between these two there exists a force of repulsion. That means between two like or same charges, there exists a force of repulsion. Between two unlike charges, that is like plus Q and minus Q, there exists a force of attraction. Total charge in the universe remains constant. Second method is induction method. In this induction method, the first body is positively charged and second body is neutral, but they are separated by a certain distance. Then due to induction method, on the second body near to the surface becomes opposite charge will be developed, and far from the surface opposite charge to the first surface will be developed. Okay, two bodies which are having positive charge and the second one is neutral. Now they are in contact each other. So when it is separated by a distance d, the opposite charge will be induced near to the surface and the same charge will be induced on the second surface. Okay. So that means the total charge remains q dash equal to minus q multiplied with 1 minus 1 by k. 1 minus 1 by k, where k is called dielectric constant. Dielectric constant. For metals, k is equal to infinity. So if we substitute the value here, q dash equal to minus q multiplied with 1 minus 1 by k. 1 by infinity means 0. So you will get only minus charge. Minus charge in this diagram, you are getting minus or not. That means opposite charge will be induced. That is the second one. Next, third point is frictional method. Frictional method, or it is called rubbing method. Rubbing method. So in this frictional method, let us consider a positive glass rod which is positively charged, and around it a silk cloth is rubbed. Silk cloth is rubbed with it. This is called a silk cloth. This is a glass rod. Compared to the surface, both the surfaces are different. Okay. Now the glass rod rubbed with the silk cloth, then the charge, negative charge acquired by the silk cloth and positive charge acquired by the glass rod. That means opposite charge will be induced. Okay, will be developed on the two surfaces. So when it is getting negative charge, if a body is getting the negative charge means, for getting the negative charge, electrons are gained. That means mass becomes increase. For getting positive charge, electrons loss. That means mass becomes decrease. Okay. Next, the linear charge density. Linear charge density is indicated by lambda. For example, if you consider a wire, for that wire only length and charge is present. Length and charge is present. Then you can write that charge is equal to lambda is equal to small element dq dl. Dq by dl is called linear charge density. Units coulomb per meter. Coulomb per meter. Next one is called surface charge density. It is called represented by sigma. That sigma for any surface properties, like sigma equal to dq by dA or q by A, coulomb per meter square. Okay. Next, for third one, volume charge density. That is represented by rho. For spherical surfaces, rho equal to dq by dV or q by V, coulomb per meter cube. To get the dq, you can write like this also: rho dV, rho area multiplied with the small element dr or dl, like that. Okay, these are about the charges. Charge density, linear charge density, surface charge density, or this is also called the areal charge density, volume or cubical charge density. Okay, thank you for watching. All the best.